Hello friends, welcome to all. Myself Vishal Jogidas. Today we will discuss about high voltage engineering and introduction to high voltage and need of high voltage. What is high voltage? High voltage is specially referred to electrical power system. We will see one diagram. At Kaptai, we generate 11 kV to 21 kV. Then it is a step-up transformer is used to raise the voltage to 132 kV or 230 kV, and then there is a long transmission line used to carry the power to Dhaka. As we know, Dhaka is the capital of Bangladesh. Then step-down transformer is used to reduce the voltage to 33 kV. And then step-down transformer is used to reduce the voltage to 11 kV. Then another step-down transformer is used to reduce the voltage further to 400 volt suitable for end user. And then domestic users get electricity at 230 volt single phase. So this is the process. First 11 kV is generated, then it is step up to 230 kV, then 230 kV is transmitted, and it is reduces to 33 kV and then 11 kV and 400 volt in 3 phase and 230 volt in single phase. So now what is high voltage? If the voltage is below 11 kV, then it is considered as a low voltage. Then if voltage is in between 11 kV to 100 kV, then it will be high voltage. If the voltage is in between 100 kV to 400 kV, it is very high voltage. If voltage is 400 kV and above, then we can say it is a extra high voltage. And if 1000 kV and above voltage is there, then we can say it is a ultra high voltage. So this is the range of high voltage. Levels of high voltage, we have already seen all these levels: low voltage, high voltage, very high voltage, then extra high voltage and ultra high voltages. However, the exact magnitude of these levels vary from country to country. Hence, this system of technical terms for the voltage level is inappropriate. In most part of the world, even 400 volt is considered to be high voltage, since it is dangerous for the living being. Hence, it would be more appropriate to always mention the level of voltage being referred without any set nomenclature. So this is the criteria. Now, why high voltage? Basically, it is required for transmission lines to be able to transmit more power over the same line. Now we will see fundamentals. One end is at Kaptai and power is transmitted to Dhaka. So here we can see current is I. Equations for power is P is equal to VI cos phi. So loss in a transmission line will be I square R, where capital R is the resistance of the line. Okay, now if we double the current, then what will happen? Current will be 2I, and new loss in the transmission line will be 2I square into R. It means equal to 4I square R. So if we double the current, then the loss will be 4 times. So it is not as advisable. Therefore, we conclude that it is not wise to increase the line current to transmit more power over a line, keeping the voltage same. So this is not wise decision. Now see, we will keep current constant and we will increase voltages. So here we can say we have used transformer and we are increasing the voltage to 2V. Then therefore we see that if the transmission line voltage is increased, it is capable of transmitting more power without increasing the power loss in the line. So this is the reason why we are interested in high voltage. Now fields of application of high voltage. One is power system engineering, then research laboratories, then industries, and nuclear research and particle accelerators, electrostatic precipitators, then automobile ignition coils, medical applications like X-ray machines. Interested students may find new areas of application of high voltage. What we learn in high voltage engineering? Testing of high voltage equipments like power transformers, bushings, circuit breaker, insulators, cables, etc. Usually tests are done at a voltage much higher than the operating voltage, because at normal voltage it is also called as rated voltage, but we have to test the equipments with more than the normal voltages. Generation, measurement and control of different types of high voltage. Failure mechanism of high voltage equipments caused by high voltage stress. Breakdown mechanism of different types of insulating materials. For example, solid, liquid, gas, vacuum, under different types of voltages. It means AC, DC or impulse voltages. Few future prospects of high voltage. For cosmopolitan cities, overhead distribution lines are not allowed anymore. High voltage underground cables of compact size is the solution. Compact all-in-one fixed and forget type GIS substations are required in near future. High voltage has some residential and industrial applications like water treatment plant, insect killer or repeller, exhaust air purifier, etc. Interested students may add new names to this list. Now AC high voltage. Here we can see the sinusoidal wave. In x-axis there is a time in millisecond and in y-axis there is voltage in kilovolt. So it is a 100 kilovolt power frequency AC voltage. Now what will be the amplitude? Suppose it is said that the voltage is 100 kilovolt, then this peak value is, its peak value is 100 into 10 raised to 3 into root 2. It means it will be approximately equal to 140 kilovolt. So this is the amplitude. And what will be the time period of half cycle? So if the frequency is 50 Hz, then the time period will be 10 millisecond for half cycle and it will be 20 millisecond for full cycle. In high voltage engineering, we should always be careful about the peak value of the AC voltage, because this is the maximum voltage in the system and may be responsible for initiating breakdown or failure. Now DC high voltage is 100 kilovolt DC voltage. What will be the amplitude? It's a simple, it is a constant voltage, so the amplitude is 100 kilovolt. Now lighting impulse. This is the typical impulse waveform. It is 500 kilovolt peak. What will be the peak value? It is 500 kilovolt. At T1 we can see there is a 10% of voltage. At T2 it means at 90% of peak, and from this T1 and T2 we can find wave front. It is equal to 1.25 into T2 minus T1. Here we can see at T3 there is a 50% of voltage. So from this we can find wave tail. Wave tail is equal to T3 minus T0. So this is the typical lighting impulse.